Whenever, Emmanuel.
Okay. Hello. My name is Emmanuel, and I will be giving an intro to malware or malware. I prefer to call it malware for reasons. But it's a series, and it goes. This week is like intro to like malware and reversing itself. Then as it goes on, it's more like reversing in different OSs. So like things that I've done personally, like the Android malware, iOS malware, and so on. So, yep. Who am I? I'm a third-year C6 student. I'm the tech lead. And again, I call it malware, not malware. And I have a pet potato. I need a name for it, so if you have a good name, just tell me. And I just found a new interest in reversing, so yep, let's start. So what is malware? It is a malicious software, pretty much anything meant to make the user life really hard to do, it's intended to break into or damage a system without like a user input and stuff like that. And why do malware exist? And this is because of bugs in softwares. So you can see there's two types. There's the zero-day attack and zero-day exploit. A zero-day attack is when, well, before we talk about that, what is a zero-day exploit is pretty much a flaw in a system that's not known to the developer, and it exposes a vulnerability to anyone out there. And the attack, which is zero-day attack, just uses that flaw to exploit. Well, a zero-day attack happens when a flaw actually exploits that vulnerability in the system. So there are multiple types of malware. You guys probably know some of them. But for this talk, I am going to talk about these three ones: the adware, rootkits, Jogen, and ransomware and viruses. Obviously, there's more. As you can see on the picture on the right, there's the worms, there's spyware, keyloggers, and all that fun stuff. So first one, adware. Well, I believe most of us would have had an encounter with this, like in the 2000s, I believe. Where you go to a website or you download a software you're not supposed to, and you get free pop-ups. So what is the goal? It's just to make money, and it could be also just for just to make people's life really in pain. Just randomly just spam them with things they do not care about, but the overall goal is just to make money, and it's mostly used by scammers. I believe that's yeah. But these are some examples of some adware from like 2017. I've actually never heard of this one. I had to get an example, but those are some of those examples of adware. And rootkits, okay. We love rootkits. Maybe not BSD. It's fun, but it's a topic for another day. But they are meant to just hide in your system without you knowing. And they before it's being used maliciously, the whole idea of rootkit is mainly for sysadmins to have system level access to your computer in case they have to fix a bug in the kernel. So rather than waiting for the patch from the vendor, they can just do like a quick way to solve the bug in the system. But nowadays, attackers use it to hide their activities on whatever system they compromise. So like they hide the files, specific files they need, and processes that they spun up, and sometimes they hide what's the word? They hide open ports, so you cannot tell when they are connected to their C2 service and stuff like that. And examples of them is the first one is Reptile. A lot of people use that, especially in our lovely ISTS competition. Well, in all the most of the competitions, we sometimes use Reptile. So that's that for you. And it was hard to find a Windows rootkit, but we have one made by one of our fellow students, Bill, Spectrum. It's a kernel level Windows rootkit. It's a rootkit, so I guess it does whatever rootkit does. Yeah, and to the right is a picture of Reptile. Yep. Jogen. This is just a software that disguises itself as a legitimate program, but behind the scenes, it's just not a good one. So, and the goal is to, yeah, like it says, get more malware to the system. But that depends on the attackers, depends on what the attacker really wants. Sometimes they have a legitimate malware program to get on your computer just to do, to use your resources to do to mine Bitcoins on your system. So, but the overall goal is get more malware to your system. It's also like an initial foothold to your system too. And the one of the two of the famous ones are the Emotees and the Zeus. I believe the Zeus malware is actually now not open source, but it's been leaked. So if you want to read some C code, it's on GitHub, so you can have fun with that. Ransomware encrypts users' victims' files. Pretty straightforward. Get more money by encrypting your data and forcing you to pay to get them back. And there's different ways to get this on a victim's system. That could be phishing, malicious documents, or again, Jogen as a first step to download more malware. And of course, we know Wannacry. That's the beautiful picture over there. And I believe right after mine, we are going to get a walkthrough of how to reverse Wannacry. So that's going to be fun. And viruses. It alters the way the computer works, designed to spread from computer to computer, and can inject itself to other programs on the system, more like injecting into processes to get like a root access permission, so stuff like that. These are some of them: I Love You, Stocknet, and the Morris Worm. I believe either the Morris Worm or the I Love You were like the first main viruses at the beginning of like computer security. I might be wrong on that, but. And okay, this was interesting to me. How often do whatever OS gets malware? So usually I always believe that it was Windows that gets more, but that's not the case anymore. It's now Mac OS. The reason because of that is because something with stocks and stuff like that. I do not remember. But yeah, now Mac OS gets, according to this according to Malwarebytes, starting from last year, the rate at which Mac OS gets malware has increased, I believe, 100%, they say. And obviously it's going to get higher because I think people are switching over to using Mac servers as servers. And yeah, I thought that was really interesting. Okay, now let's talk about some reversing. All you have to do reversing is just run strings on your binary, and that's it. You're done. That's all you need to do, man. Okay, so what is reversing? Why do we do that and all that stuff? Well, reversing is simple. It's just trying to disassemble and analyze a product. It doesn't have to be a software. It could be hardware. So it's just the process of reversing, trying to breaking down a device just to see how it works underneath. And some people do this just for curiosity, but others do it so they can copy it and resell it as a new product. But that's not what we do. We are doing this for curiosity. We just want to see how this works. And yeah. And how do you reverse? You can, again, like just run strings on it or do GDB, and that's it. But yeah, there are 4 main steps in reversing. And the first one is static analysis. Well, basic static. Static analysis is just you examine the malware, or in this case, yes, in this case, malware is the case of examining the malware without actually running it. So it's like you're looking at the metadata in the plain text you see when you run strings on it, just to see if you can find maybe like an IP address or like a file name, just to like get a idea of what the malware is going to do before you even run it. And like again, the basic static is pretty much looking at the metadata. And advanced status is you use a disassembler to look into like the assembly of what the program or the malware does. So you use stuff like IDA or Ghidra. Actually IDA, not Ghidra. IDA Pro, you can use that to like look at the malware instructions. So if that's, in order to do that, I think you don't have to know a lot of assembly, but it's good if you know some. It helps the process. It helps you understand the process of what's going on. And the next step is basic dynamic. And that's you running the malware in a safe environment, make sure it doesn't escape, and you just observe what it does. So you just run it like it would run on a victim machine. You don't have to set up anything. Well, basically, you do not need to set up anything. You just have to run it and see what happens. Like, for example, the Wannacry. When you run that, you notice that the files on your system, the extension changes to something else. And it reboots, and you notice that your wallpaper is now the ransomware note saying you should pay up. So that's just basic dynamic, seeing what happens when you run the malware. And advanced dynamic is you attach the malware to a debugger so you can see the instructions that happens every time, pretty much step by step as you run the malware. So this can help you like know the flow control of how the malware does. Like if it has an if statement, you can see if it jumps from this, if it skips like the 4 interesting like instructions to another ones. It's just attaching a debugger and looking at the instructions as you run it. The way I see it is that it's like advanced static, because you see the assembly instructions with it as you run it. So that's how I think about advanced dynamic. Yeah, and these are some of the tools you can use if you want to really get started. Like for basic static, again, strings. You can also use VirusTotal. This website usually does the static analysis for you, because when you upload the malware, and if they have it already, it tells you like all the metadata, like the strings, if it's packed or not, if it's obfuscated, if it tells you any potential POC, I believe, and pretty much all information they can get about the malware, VirusTotal usually has them. And PID, well, that's for Windows, but what it does is checks if it's obfuscated or not. And yeah, basic dynamic. Like I said, usually basic dynamic, you don't have to do anything. But let's say you are in a safe environment and the malware, you need to connect to a server. Obviously, you don't want to give it internet access. So you can set up a dummy web server and point every web traffic to your web server and see what type of request it sends. And that can help with the process with basic dynamic. You can also do Process Explorer, that's for Windows. So when you run the malware, you can see if that malware spawns like other processes, and like see exactly processes wise. It tells you if there's any new processes being spawned, and if it, yeah, just tells you about the process. Advanced static, well, there's multiple, but this one's I mostly use IDA Pro and Ghidra. Yeah, IDA Pro and Ghidra. I use that a lot. And for advanced dynamic, we have these three main ones: OLI DGB, IMM DGB, and X64 DBG. And the first one and the last one are free, and the middle one is obviously you have to pay for that. I think that's it. Okay, is there any questions? I know I went kind of fast, but it's an intro, so.
There's one question from a mystery person. Can you explain obfuscation?
Obfuscation, yes. So it's a way to kind of like when you run strings on a binary that's not obfuscated, you would see plain text. You would see text you can actually read. With obfuscation, it kind of just gibberish that's those kind of stuff. So it's a way to make it hard for a malware analysis, malware reverse engineers to like not figure out your malware, and like it makes it hard for reverse engineers to tell what like strings are important in your malware, and yeah. It's pretty much just gibberish text that you see when you run strings on a binary. Oh yeah, and by the way, strings, if I think I didn't explain that, but strings is just a program that runs through, I think it looks at the X code of that binary and sees and prints out every printable ASCII characters to your screen. So, yeah. Any questions? Any more questions? I guess not. So next week we will be talking about Android reversing, something I think I know a little bit more. 2 weeks. 2 weeks? 2 weeks from now.